Academic discourse is how students process ideas, make connections, and deepen understanding through meaningful conversation. As you plan your lesson, consider the prompts that will spark discussion, how students will engage with the content and one another, and what supports, like sentence stems or discussion protocols, will help every learner participate. Watch how this teacher scaffolds academic talk by giving students time to think and write before they speak, providing low-stakes opportunities to share ideas, and using sentence stems to support meaningful discussion.
We're going to go through a 10-minute little math warm-up today, okay? So to begin, I want to introduce the idea of a mobile, or sometimes it's a mobile. The kind of mobile that I'm talking about is a lot of times in kids, like babies' cribs, and they're hanging over them, and they're dangling things. Yep.
So they spin around?
They can spin. And sometimes they're not round. Sometimes it's just flat. And here's a picture of the kind of mobile that I'm talking about, okay? But what does this have to do with math? So as we're thinking about what does this have to do with math, the first thing I want you to think about is, what do you notice? And you have paper and pencil, so I want you to jot down, what are some of the things that you notice about this mobile? For those of you that have finished, you're going to start a new list of what are some of the things that you wonder when you look about this, that you wonder, that you're like, I wonder why, or I wonder how. Share with me, what are some of the things that you noticed? Yes.
I noticed that I see more purple hearts than red.
More purple hearts than red. Red what? What is that?
A trapezoid?
Trapezoid, yes. Okay. What's something else, something different that somebody else noticed?
This side has less than that one.
This side has less what?
Shapes.
Than that. Okay, excellent. What do you wonder?
Why they're not all the same?
Okay. Can you share the one that you have, one of your wonders?
I wonder how we'll solve this problem.
Solve the problem, because I did say it's related to math, right?
Yes.
So then what kind of problem is it? So what would happen if I hung another heart on this side? It would be unbalanced. So what is it now? It's balanced. What kind of math symbol do we use when something is balanced? What kind of math symbol do we use when two things are balanced?
Equal?
An equal sign. So let's talk about this. Now I'm going to tell you that we don't know what the value of the trapezoid is, but we do know that the value of the heart is 2. So I want you to take a moment, go ahead and draw this real quick on your, it doesn't have to be perfect hearts, doesn't have to be a perfect trapezoid, but go ahead and draw it so that way you can take some notes. Once you get it drawn, now see if you can solve. What are we solving for?
How much the trapezoid is?
The trapezoid is what is the unknown, right? It's what we don't know. So see if you can solve. Now you're going to turn and talk. Here are some different stems. I found the trapezoid was this because of this, or maybe you disagree with them and just say, I disagree. Don't say, no, you're wrong, but use one of these stems.
I found out the trapezoid is 4 because the way I did it was, if it's unbalanced, whenever I took away the heart and I took away another one of the hearts from the other side, it would only be 4 and it stays balanced.
I got the same, but I did it differently than yours. Since these were all 2, I counted them up and I got 6. So the trapezoid was 4, and then the heart was 2, so that's how I got 6.
I did that same thing as well, right here. First, my strategy is different because as you see on the mobile, we only have one trapezoid and multiple hearts. What did you do?
So I got a 1 because there's only one trapezoid, and if you got a heart, that equals a 2.
I disagree because on one side of the hearts, I see that we had 3 hearts out there, 2, 4, 6. So I added 3 of the hearts together, and that got to be 6. And then I also did 3 times 2, which also equals 6. So does that make sense to you? Okay.
Okay, so most of us, I think, it was pretty easy, right? But I'm more focused on the strategy and how you guys are talking to each other, because as we go throughout the year, you're going to have to talk with each other about the math. So what solution did we get for the trapezoid?
4.
4. So now let's talk about how we got the 4.
I know that there's 3 hearts on this side and the hearts equal 2, so I did 3 times 2, which gave me 6, and then 6 minus 2 would give you the trapezoid length, so which it was 4.
Okay, I like how you multiplied on this side because you were repeating the same number, and then over here you did 6 minus 2 to get you your 4, right? Okay. Somebody that did a different strategy?
I did mine. I envisioned it on a balance scale, and then what I did was I took away one of the 3 hearts, and I balanced it out by taking.
Okay. Hold on, let me change colors. You took away one of the 3 hearts.
Yeah, so then that side was heavier,
So then, which side is heavier?
left side.
The left side is heavier.
and then I took away the heart, and then I balanced out so that I would be 4.
Okay. So it's in balance again. So you said this trapezoid has to be the same as those 2 hearts that are left. Excellent. This is going to lead us up into solving equations, because when we solve equations, we have to keep them equal. And I love how when you took something away from each side, it stayed in balance, because that's a critical move when we're talking about equations. Okay, excellent job.
Remember, rich academic discourse doesn't happen by chance. It requires intentional planning for the conversations you want students to have. Incorporate low-stakes opportunities that get every student talking. Scaffold discussions by giving students time to think, draw, and jot down their ideas before they speak, and use discussion protocols to guide meaningful, productive conversations.